Good morning and welcome to today's lecture 08 under Elementary Mathematics 1. We want to consider quadratic polynomial inequalities. We have two examples here. The first example is to solve x squared minus 4x minus 3x minus 4 less than 0 and find the greatest integer in that region. The second question is to solve 6x squared minus 7x minus 5 greater than 0. Now, let's see the answers. For the first question, x squared minus 3x minus 4 equal to 0. Just try to solve that, ignoring the inequality for now. We can factorize this as x plus 1 into x minus 4 equal to 0. Usually when we solve this, we have x equal to minus 1 and x equals to 4. So the solution for x squared minus 3x minus 4 less than 0 will be one of the intervals or both. That is, from by the left you have minus infinity and minus 1, first subinterval. Then the second subinterval should be minus 1 and 4, in line with our solution here. And then the final one should be from 4 to infinity. How do we find the correct one here? So we have to make a table, a simple table that will show us the solution. This table is made up of how many columns here? First column, second one, third one, fourth one, and fifth columns. For the first column with the heading interval, you have to line up those intervals. That is minus infinity, minus 1, minus 1 and 4, and 4 and infinity. Then for the second column, test value x, you choose any number in between that your interval on the first column. For instance, between minus 1 and minus infinity, we can get minus 2. The smaller your answer, the better for you to handle. And between minus 1 and 4, you have 0 there. You have other number, but choose the simplest one like 0. Between 4 and 8, I have 5. Of course, you know, after 4, the next number is 5. You can check 50, 100, but the simpler the number, the better for you to handle. Then let's evaluate those two factors of that quadratic expression. First one is x plus 1. When x equal to minus 2, what should be x plus 1? That's minus 1, of course. If x is 0, it becomes 1. If x is 5, it becomes 6. What of x minus 4? If x is minus 2, it becomes minus 6. If x is 0, it becomes minus 4. And if x is 5, it becomes 1. If you multiply these two together, these two values on these columns, minus 1 times minus 6 becomes 6. 1 times minus 4 becomes minus 4. 6 times 1 becomes 6. That is under the product x plus 1 into x minus 4. By which of these values, according to the problem, is less than 0? Of course, you see, minus 4 is less than 0. And which interval has that solution? That is minus 1 and 4. So the solution to the problem becomes this interval, minus 1, between minus 1 and 4. Yes, that's the only number that's the only interval with a negative number in the last column. Then, of course, we know that the greatest integer between minus 1 and 4 is 3. Question 2. The solution of question 2. As we handle the first one, we try to factorize 6x squared minus 7x minus 5 equal to 0. And we have 3x minus 5 into 2x plus 1 equal to 0. Now, usually, we can solve 3x minus 5 equal to 0 and 2x plus 1 equal to 0 to get x equal to 5 over 3 and x equal to minus 1 over 2. Again, for us to do this, we have to use this solution to form some intervals, subintervals. The first one from the left is minus infinity and minus half, followed by minus half and 5 over 3, and lastly 5 over 3 and infinity. Good. Now, which of these is the correct interval? We have to form a table again, just as we did before, and then choose your test values as -1, 0, and 2. Try to compute 3s minus 5, 2s plus 1. Try to also multiply and have 8 minus 5 and 3. In this case, we are looking for positive value of this product, 3s minus 5 into 2s plus 1. Which one bear the positive? You can see the first interval has 8, the last interval has 5. So 2 of them satisfy that condition. So we take the union of the 2 intervals as our answer. That is minus infinity, between minus infinity and half, union between 5 over 3 and infinity. That's good. Then, what about the cubic polynomial? The same situation will apply. We have more than 2 factors. Here, we have 3 factors for this problem here. X minus 3 into x plus 1 into x plus 5 greater than or equal to 0. Of course, it's easy to solve. When you solve that, you have x equal to 3, x minus 1, and x minus 5. The solution of this will be one of the intervals. You can see the intervals are many now. From the left, you have minus infinity to minus 5, minus 5 to minus 1, minus 1 and 3, in that order, increasing order, and 3 and infinity. So find the correct region that describes that inequality by creating a table in this form, just as we did before. Look at your intervals. These are the test values. These are the values for each of those factors of that quadratic expression. Then if you multiply the 3 of them, you have this. If you multiply this 3, you have this and that. So which one is greater than or equal to 0? That is the second and the last. So the union of the second and the last is this one now. The union of minus 5 to minus 1, union 3 to infinity. That is the solution to this problem. Now, what about a rational inequality, where you divide one polynomial with another? Here, this method is for you to look at the numerator, equate to 0, equate the denominator to 0 again, and solve to get your answers as minus 4 and 5. Then use it to form intervals again, as we did before. As you can see, between minus infinity and minus 4 and 5, 5 and 8, one of them or 2 of them might be the solution to the problem. Let's look at the table again. The same procedure, test value minus 506 in that order. For the 2, the numerator and denominator, these are the values you have. So if I divide this by this, I get 1 over 10. If I divide this by this, I have this. If I divide 10 by 1, I have 10. Now, which one is negative here? You can see the second one, between minus 4 and 5. And that defines the solution to the problem of this inequality. So simple to handle? Yes. Just pay attention. Look at it gently and see how I did it. Just gradually. You can follow. Yes. 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 And lastly, we have this. Thank you for watching. Thanks. That's good.